Fundación UNAM, en su compromiso por la divulgación de la ciencia al alcance de todos, continúa con la tercera temporada del ciclo de documentales Nuestra Nueva Realidad, Jueves de Ciencia, en conjunto con el Consorcio de Universidades por la Ciencia, transmitido por la señal de TV UNAM y nuestras redes sociales. Cada jueves presentamos temas relacionados con el gen, una historia personal, el misterio de los cristales gigantes, luz en la Tierra, H2O, la molécula que nos hizo, viajes geológicos, así como el comportamiento de las plantas. No te pierdas las transmisiones los jueves en punto de las 15 horas por la señal de TV UNAM y en www.fundacionunam.org.mx.
Bienvenidos al ciclo de conferencias Universidades por la Ciencia, organizado conjuntamente por Fundación UNAM y el Consorcio de Universidades por la Ciencia, que agrupa universidades y centros de investigación en México, Estados Unidos, Inglaterra, Brasil, Argentina, Chile. El ciclo de conferencias es organizado en forma conjunta y el día de hoy tenemos una conferencia muy especial a cargo del profesor Alik Ismail-Zadeh, quien es investigador en el Instituto Tecnológico en Karlsruhe, en Alemania, y es también un miembro distinguido en la Unión Geofísica Americana. Nos acompañan en el presidium, en el panel, el presidente de Fundación UNAM, Dionisio Emid, la secretaria internacional de la Unión Geofísica Americana, Ligia Pérez Cruz, y nuestro conferencista invitado, Alik Ismail-Zadeh, y la directora ejecutiva de Fundación UNAM, la licenciada Araceli Rodríguez. Muy bienvenidos todos. Welcome to the University for Science lecture series. This is organized by the UNAM Foundation and the Consortium of Universities for Science with universities and research centers in Mexico, USA, United Kingdom, Brazil, Argentina, Chile. The conference cycle is a joint effort, and for this conference we have also the partnership with the American Geophysical Union, which is one of the largest scientific societies in the world. We have in the panel the president of the UNAM Foundation, Dionisio Emid, the International Secretary of the American Geophysical Union, Ligia Pérez Cruz, and our speaker, the Professor Alik Ismail-Zadeh, who is in the Karlsruhe Institute of Technology in Germany, and is a fellow of the American Geophysical Union. Welcome all of you, and thanks for accompanying us in this very special lecture. The lecture is on advancing frontiers in disaster science, which is one of the major interests of Professor Alik. And Alik is also a very good friend of Mexico, having been here many times. So it's for us, we're very proud having him this time, and we are very grateful to see him. With this, I will pass. We will go back and forth in English and Spanish for the introduction. The lecture will be presented in English, and we welcome comments and questions through the UNAM Foundation platforms, and also through the UNAM offices in Tucson, in San Antonio, UK, and Germany. Thanks very much, all of you. Questions and comments are welcome in either Spanish or English. And with this, I will pass to our president of the UNAM Foundation, Dionisio Emid. Thanks very much and welcome all of you. Muchas gracias y por favor, Dionisio Emid, nuestro presidente de Fundación UNAM.
Muchas gracias, Jaime. Muchas gracias, Ligia, por ayudarnos y por acompañarnos otra vez en una de estas presentaciones del Consorcio de Universidades por la Ciencia. Muchas gracias a nuestro conferencista de hoy, al profesor Alik Ismail-Zadeh, y pues nos sentimos muy contentos y muy orgullosos de continuar con estas presentaciones. Hemos subrayado en ocasiones anteriores que fue un acierto establecer este consorcio y que nos permite contar con la participación de expertos de todas partes del mundo, hoy precisamente con un experto de un instituto que está en Alemania. Y esto pues acredita la versatilidad de este consorcio y acredita la gran riqueza de poder escuchar a expertos de muy distintas partes del mundo que justamente nos comparten investigaciones en curso, precisamente para poder mantener un intercambio y un diálogo en donde nos parece a nosotros que lo más fructífero sería que muchos jóvenes estudiantes que están tratando de definir cuál es su opción profesional, pues se vean motivados con lo que aquí escuchen para poder elegir alguna de las especialidades que aquí se han dicho. De manera que esa es una motivación que nos gustaría que tuviera presente el profesor, porque queremos que muchos alumnos precisamente se motiven a este intercambio, a este diálogo, y como otras veces hemos dicho, creemos que lo más estimulante pues sería contar precisamente con este diálogo fecundo entre investigadores, entre estudiantes, entre quienes están estudiando también su maestría o su doctorado alrededor de estos temas. Nosotros hemos subrayado que todo este marco de presentaciones se inscribe en lo que hemos llamado la nueva realidad. Y la nueva realidad en este caso pues implica que tengamos un mejor conocimiento del planeta. Y yo creo que aquí se inserta pues uno de los propósitos básicos que las lecciones del planeta nos han dejado. Cuando se habla de la ciencia de los desastres, se habla también de la posibilidad de reflexionar sobre cuáles son los riesgos que pueden incurrirse en la vida del planeta y cómo podemos prepararnos para enfrentarlos mejor. Y estos riesgos pues son de muy distinta naturaleza. Hoy con el cambio climático pues se han hecho más evidentes algunos de ellos en términos de sequías, en términos de tormentas, en términos de huracanes, y los hay también de otra naturaleza, pues también tenemos riesgos de temblores, riesgos de acomodos de la tierra, etcétera. Y mientras mejor conozcamos cómo funciona el planeta y mientras mejor nos preparemos a estas posibles adversidades, estaremos escuchando más lo que nos dice la Tierra respecto a su comportamiento. Hemos tenido en el ciclo de documentales por la ciencia una breve descripción de cada uno de los continentes y el próximo jueves tendremos otro más, y en estas presentaciones también se han acreditado algunos de los riesgos que justamente se generan de este comportamiento de la Tierra, que es un planeta vivo, que debajo del piso donde nosotros caminamos se encuentra una gran riqueza de vida de todo tipo, vida mineral, vida animal, vida de volcanes que se están generando. Y entonces toda esta motivación y conocerla mejor, yo creo que es una experiencia y una lección que la Tierra nos está dando y a quien nosotros tenemos la obligación y el deber de escuchar. De manera que por todas estas razones, pues nos es muy grato contar con la audiencia que se abre a través de estas redes, con la participación del profesor Ismail-Zadeh y con la participación también, que nos harán el favor de auxiliarnos, de Ligia y de Jaime Urrutia, que como ustedes saben, pues tiene el triple carácter de integrante de la Junta de Gobierno de nuestra universidad, miembro del Colegio Nacional y para orgullo nuestro también, miembro del Consejo de Fundación UNAM. pues por todas estas razones les damos la bienvenida y les damos también las gracias por acompañarnos y estamos dispuestos a escuchar esta presentación que nos hará el profesor sobre estos temas y los avances de la ciencia del desastre, de la ciencia del desarrollo sostenible. Muchísimas gracias y vamos a estar pues muy pendientes de lo que nos pueda decir y aconsejar en su presentación. Gracias a todos.
Ok, hola, ¿qué tal? Buenas tardes a todos. Para mí es un gusto estar aquí presentando precisamente a este gran expositor, a este gran investigador que tenemos ahora. Me voy a permitir presentarlo en inglés y hablar un poco acerca de la sociedad, de la Unión Geofísica Americana. The American Geophysical Union is a non-profit organization of Earth and Space Science. The AGU activities are focused on the organization and dissemination of scientific information in the interdisciplinary and international fields within the Earth and Space Science. Our mission is support and inspire a global community of individuals and organizations interested in advancing discovery in Earth and space sciences and its benefit for humanity and the environment. We also dedicated to educating and inspiring the next generation of scientists needed to advance this mission. The AGU College of Fellows developed the Distinguished Lecture Series program to connect AGU Fellows with the students from across the globe. This program will provide the students, especially those without access to Earth and space scientists, an opportunity to be inspired by a learner from AGU Fellows. The lectures provide a high-level synthesis of a specific field for general science audience and will focus on grand challenges and societal impacts, like in this case. Today, it's my pleasure to present a distinguished lecture of College of Fellows from AGU, the Professor Alik Ismail-Zadeh. Professor Alik is a chief scientist and research professor and the scientific leader of the group of computational geodynamics and geohazards modeling at the Institute of Earthquake Predictions, Theory and Mathematical Geophysics from the Russian Academy of Sciences in Moscow. And also is senior scientist at the Institute of Applied Geosciences in Karlsruhe Institute of Technology in Germany. Professor Ismail-Zadeh is a mathematical geophysicist known for his contribution to computational geodynamics and natural hazard studies, pioneering work and data assimilation in geodynamics, as well for outstanding service to the Earth and space science community. Research interests of Ismail-Zadeh cover geodynamics, seismology, sedimentary geology, and tectonics, including research for hydrocarbon industry, geohazard, risk analysis, science diplomacy, and history. He has received many international awards and honors. I will only mention a few. He is a fellow of the International Science Council, is the ambassador. He received the Ambassador Award of the American Geophysical Union in 2019, is fellow of the American Geophysical Union, and also is fellow of the International Union of Geodesy and Geophysics, a member of the Academia Europea, and he is an honorary fellow of the Royal Astronomical Society. Today, he will give the talk on advancing frontier in disaster science. Please welcome and thanks for being with us and share your knowledge about this very interesting and topic about disasters, about natural hazards. Welcome, Professor Alik.
First of all, thank you very much, Ligia. Thank you, Dionisio and Jaime, for inviting me to this lecture. It's a great pleasure to give the lecture to the very big auditorium who comprise the people from Latin America, from North America, from Europe, and other places. Yeah, definitely, muchas gracias to everybody who are present. Let me share my screen. Do you see my screen?
Yes, we can see.
Yes. Okay, great. Yeah, thank you. Okay, today's lecture is about disasters, their societal implications, and disaster science, which is aimed to contribute to risk reduction. I shall try to answer several questions, societal important questions, scientific questions. For example, such as why, where, and when hazards turn to become disasters. Let us start, and I take you to the middle of the 19th century, 18th centuries. You see here the map of Western Europe after the two treaties, Utrecht and Rastatt treaties, 1713. It was a time when the countries were quite prosperous, trade were developing dramatically. The countries after the several wars becomes really at the very high level of the development. And this era, this time was called the Age of Enlightenment. As scientists told, the world appeared to become stable, calculable, and predictable. And as you probably know, two eminent scientists, one of them Isaac Newton, who predicted the course of the planets, and another Gottlieb Leibniz, who expanded the notion of optimization from mathematics and physics to metaphysics, to philosophy. And they were standing for the spirit of the for this spirit, I mean the Age of Enlightenment spirit of the 18th century. And Leibniz wrote, "We live in the best of all possible worlds." That was a time, that was the Age of Enlightenment. But everything changed within 1 day. It was the 1st November 1755 when the Great Lisbon earthquake occurred. As you know, the Catholic world celebrate on the 1st November the Day of All Saints. And the people early morning went to the church, and the earthquake started shaking and the buildings were collapsing. People who could escape from this really disaster went towards the water to take a boat and escape from this city, which was started already in fire. And unfortunately, they met tsunami. In 1 year later, the philosopher Immanuel Kant wrote, "If humans are building on inflammable material, over a short time, the full splendor of their edifices will be falling down by shaking." Is it the reason, he asked, to blame the providence, to blame the God? This is a great meaning. Already at that time, more than 250 years ago, the philosopher, even not scientist, but philosopher, put under the question, is the natural events a result of disaster, or probably non-natural events are responsible for disasters? Not events, but conditions. Let's just define what today we understand when we are speaking disasters. United Nations Office for Disaster Risk Reduction treat the disaster or define the disaster as a serious disruption of the functioning of the community or a society at any scale due to hazardous events interacting with conditions of exposure, vulnerability, and capacity, leading to one or more of the following: human, material, economic, or environmental losses and impact. On the left-hand side, you see the gray East Japan earthquake and tsunami devastation of these two events, and mostly because of the tsunami. Today, I will be speaking mostly about disasters caused by natural hazards, but we should remember that disaster can cause by different reasons. For example, technological or military reasons. War also creates disaster. And even I will not be speaking today about disaster created by other reasons, but we should not ignore these important issues, disaster due to non-natural events. And again, returning back to Immanuel Kant, I would like to highlight the excellent words he taught at the same book called Erdbeben earthquake, the earthquake which occurred in Lisbon. After this earthquake and just before 7 years war in Europe, Immanuel Kant wrote a remarkable note to His Majesty Friedrich II, King of Prussia. Sire, we cannot yet prevent an earthquake, but you can prevent the war. I think this is a very short message, was indeed a great message. Disaster due to non-natural events can be prevented. Well, let me remind you before I actually go to the main body of my presentation, remind you about major disaster we were facing during the beginning of the 21st century. Gujarat earthquake 2001, 2005 Kashmir earthquake. You see here the numbers of people who died, who were injured, and a lot of buildings were destroyed. Quarter or even more, sorry, it's a 1/3 million. Indian Ocean tsunami. Actually, this tsunami is compared by a few people, a few scientists, with the tsunami of Lisbon earthquake and tsunami to 1755, because it shocked the world at that time in 2004. It was the first major event which happened there. And we can ask ourselves, we scientists know about the possibility of the large event occurring in this region? I can tell, yes. There is a group of scientists investigated. I am not specifically speaking about this event, but in 1830, the earthquake and tsunami took 30,000 people within one day. Could you imagine about 200 years ago, the number 30,000? And this is something which really great event were already at this place. Modeling also shows that there is an Indian Ocean, in the Aceh Sumatra region, the large events can occur because of the subduction of the plate. 2005 Hurricane Katrina, it would never turn to become disaster if a few years before the state will approve the request of the scientists and engineers to allocate $7 billion to the engineering construction to really make more safe the dams there, the levees, and it was not accepted. In a few years, Katrina hurricane came, flooding, took away 1,800 people and more than $125 billion in damage. 2010 Haiti earthquake. Again, this could not turn to disaster. Actually, magnitude 7, it was not so large earthquake. Just several months before it, it was an earthquake of magnitude 8.8 and was not a significant disaster. So not significant deaths, no significant losses were there. It was in Chile, and 2010 in Haiti took about 250,000 lives. And here I can tell this is not only poverty, but poverty definitely is one of the first contributor to disasters, but also irresponsibility, ignorance, and also the corruption created this situation. Volcanic eruption of generated really big, if not disaster, but it's considered to be the major event, a major disaster due to the volcanic eruption, because disaster was in aviation. It was about 2 weeks, aviation stopped any flight over the Europe and even larger. You see here, there's from the Met Office on the right-hand side, the very black and gray, these areas shaded. It's the volcanic ash cloud. And it's very well known that it's when the flight goes through the ash can really, there is a very high temperature. Ash particles can really damage the engine of airplanes. And this is something which important. And at that time, the World Meteorological Organization and the International Civil Aviation Organization, they took together with the International Union of Geophysics, it's a next step to establishing scientific advisory body to give the advice about the volcanic ash propagation due to the volcanic eruption to the world. 2011, East African drought. It's a million of people were really needed. I mean, it was emergency of food, emergency of water after the failure of the 2 rainy seasons between 2010 and 2011. It's generated really the major disaster in the very big region of the East Africa. And finally, in this list of the very few actual disasters which I mentioned is a COVID-19. This is fully, entirely, in my opinion, relies on the non-preparedness and non-awareness of the society with respect to the coronaviruses and their implication. You see, it's just the fresh data. More than 6 million people lost their life during these 2 years of the pandemic. It was a #1 disaster of the 21st century. When we are speaking about the natural hazards, we assume there is a natural processes and phenomena that may cause the loss of life, injury, and other health impact, property damage, social economic disruption, or environmental degradation. We study natural hazard to understand how the phenomena of particular hazard is influence the nature. And there are many different natural hazards, and about the 300 natural hazards most recently were classified by the International Science Council and the United Nations Office for Disaster Risk Reduction. I will highlight here the one of them. It is an earthquake. It is close to my research, but the similar investigations occur in many different natural hazards and other type of hazards studies. Particularly, geodesy help us to understand the preparedness to the big event. For example, about the Haiti earthquake, in 2008, 2 years before the earthquake, scientists wrote the Enriquillo fault in Haiti is currently capable of magnitude 7.2 earthquake if the entire elastic strain accumulated since the last major earthquake was released in a single event today. I would like to also mention that the last year was another event even higher in magnitude than a magnitude 7.0. I think it's 7.3 was also in the same country, but far from the big city. And you could see that the number of losses and damages was much less than during the first event. Again, it tells that the magnitude of natural hazard not on this driver, and is not a driver actually, but it's a causing event. But drivers are something else. We will be discussing about these things later. Data-driven modeling help us to understand the dynamics. For example, in the case of earthquake dynamics of the lithosphere, and we can generate the earthquake due to the fault interaction, crustal block movements, fault slips, and to investigate the earthquake focal mechanism and other. And based on this, we can actually generate based on the generated earthquake together with observed events, or we can go forward to the enhanced seismic hazard analysis. And particularly here, I indicate the faults, major faults, and their segments where the earthquakes with 6 gray to about close to 9 magnitude, which is a lila color, it can occur within the Tibet-Himalayan region. And based on this data and based on the all observations available and the earthquake simulations during the 4,000 years, we could really enhance the hazard assessment for this region. And on the top, you see in peak ground acceleration, because the seismic hazard actually is assessed by the ground shaking, and the ground shaking due to the earthquake, due to the wave propagation, which shake the surface of the earth with some, and the measure of the shaking is peak ground acceleration or peak ground velocity. Here is a peak ground acceleration. And you see the map on the top, which is generated because of the earthquake simulations. In the middle B, it is a map which don't consider any simulation earthquake, but only consider earthquake for about 100 years in the region. And the differences between these two maps. And the differences clearly show that it's for the regions, big regions, where the large magnitude events occur not every day, not every month, not every year, but sometimes more than 300-400 years. It is a catalog of the 100 years or 200 years is not enough to present clearly the places where large events can occur. Particularly in 2007, when they first published the paper, we showed the area here at the Longmen-Shang fault, where the magnitude here, where magnitude of close to 8 can occur. Chinese scientists mentioned that it is a very high magnitude, and it's most probably the earthquake when occur will be lower than 7.5. But 7.9 magnitude event occur in 1 year after the first publication. But again, it is nothing to tell about the prediction. We just show the places where the large event occur. But again, I wouldn't like to stay here and today on the very scientific topic related to natural hazards. My topic is disasters. That's why I will briefly tell the following. Natural hazard science, it's really, we are witness of the fundamental change in the understanding of the dynamic processes of the Earth's lithosphere, hydrosphere, cryosphere, and many other spheres related to the Earth. We also have a significant progress available in preventive medicine, virology, and immunology, and many other areas of science related to hazard. Real-time and long-time monitoring of active processes associated with natural hazard using observations assist us in general with analysis, deep analysis, and modeling of the hazards. And predictability, which is quite important in understanding when and large event or extreme natural hazard event can occur is also together with operational forecasting, it's the early warning system and the hazard modeling assessment today significantly improved and available. But much is known about the physical, chemical, biological process and forcing mechanism of natural hazard. Still, the impact of natural hazard is increasing. Now we move to disaster science. Disaster science investigates the influence of extreme hazard events on social and natural environment in very interdisciplinary manner. I will tell even in transdisciplinary manner. I will be speaking about this later. Disaster science involves the notion of risk as a convolution, or simply speaking, the integration. Convolution is a mathematical term of integration with specific manner, and of hazard, vulnerability, and exposure characteristics. And understanding the way, it is not only the essay, but understanding the way how to reduce disaster risk and increase resilience. That is why it is really the interdisciplinary in terms of the social and the natural sciences, engineering, policy making, this is other aspects, and bringing the knowledge of other stakeholders dealing with the disaster risk reduction. When we are speaking about vulnerability exposure, let us very briefly mention what it is, because sometimes it differs, and I take into consideration it's some very well defined. Oh, I am very sorry, I must translate. I take a definition from the United Nations Office on Disaster Risk Reduction. Vulnerability is the conditions determined by physical, social, economic, and environmental factors or processes which increase the susceptibility of the individual, community, assets or systems to impact of hazard. And exposure is a situation of people, infrastructure, housing, production capacity, and other tangible human assets located in hazard-prone area. Well, one example about the risk as a integration of hazard, vulnerability, and exposure. This is a paper was published in 2013 in Nature by Becker, illustrating how the GEM, which is a global earthquake model, works. And they took an example from Portugal, showing the assessment from the magnitude 8 earthquake. It's a synthetic earthquake, such as the one which I discussed just earlier today, which occurred in Lisbon in 1755. First left map show the seismic hazard. I was speaking about the seismic hazard just a few minutes ago. And this is I would tell, natural scientist approach to look on the ground shaking, which were measured in different values. For example, in big Drought acceleration, or it's the old measure its intensity, which is ranging from 1 to 12 or something like that. And another, the middle, the panel showed the physical vulnerability. And this is a engineering approach. Normally, engineers look at the building environment and they calculate the fragility curves and so on, and look at the potential damage due to earthquake or other type of shaking. The last panel showed the social and economic vulnerability. And it's the best, and it's based on the susceptibility of people to the specific hazard, for example, to this earthquake which occur, or to the mobility of the people, like their age and their working condition, or also this related to economic issues, economic the indices. This is a three major components, which normally together with the exposure, but it's exposure somehow here incorporated within the physical vulnerability. and it gives a risk map. And now I will show you risk map. And a very brief view will tell you that it's integrated parameter like risk is looks very similar to the physical vulnerability. Why? Because it's like more than 250 years ago, Immanuel Kant told, buildings kill people, not earthquake. And that is a exactly scientific way to show that the causes of this disaster are earthquake, but vulnerability are the drivers of disasters. 3 years before this paper appeared, we published another paper related to the risk assessment. But I did this for the city where I was born. I was asked my colleague to collect data, who is the first author of this paper. And we did a similar things. We look at the potential building damage or the population in the city, exposure. Even more, we looked at the landslides, which can be caused by the earthquakes. And it is a very remarkable event in Baku city. And we constructed 3 models of earthquakes and or earthquake scenario. You see the G, H, and I. This is a central panel, and 3 different scenarios. And then we convolve all these things, but individually for each scenario. And we received the 3 scenarios of risk, seismic risk. And if you will look carefully, you see that it is a major area where the areas where the highest seismic risk is associated with potential building damage and populated areas. Well, there's very similar results to the results published in a few years later. But I was talking about the earthquake. You can tell that there is such methodology developed in almost all area of natural hazard. I just will show you this very interesting work which tells about hurricane surge flooding. It's very important that the hurricane develop the flooding, and flooding is it's a multi-hazard assessment of risk. And you can see the hazard comes together with vulnerability parameter to generate through some analysis which brings together is a Monte Carlo simulation and analytical analysis, comes together with the cost benefit analysis and probabilistic benefit analysis, and to tell something about the potential risk for the area if some parameters are chosen for this specific scenario which occur. Another area is volcanic ash cloud. I already mentioned that it's so important to generate to predict the propagation of the volcanic ash in the atmosphere and to transfer this information as soon as possible to the authorities dealing with air traffic. And here particularly I show the 2019 Raikoke volcano. Here it's show the place where volcano occur. And this is a map showing that immediately already on 22 June, the authorities were informed, and after that 23rd, 24th June, the data was sent. And you see here red indicate the projected or forecasted area of the clouds, and green show the real data. It's using the data assimilation, which is an important tool in the atmospheric sciences and in many other areas of earth science today. And using this methodology, it is possible to predict the propagation of ash, even volcano occur here, and within 2 days where it will be, and how to protect the flight through this ash area of the volcanic ash. Well, I showed you that it's a natural hazard is developed very well. Disaster science is doing also well together with social scientists, together with engineers. But important issue of disaster science, how it assists to make the existing and new knowledge be usable, used, and useful. That is the three words appear in the sociological studies in early 2000. And this becomes important today and in the future. How to make scientific knowledge usable, used, and useful. How to transfer this risk analysis, which I showed you very simple way, to policy making. How to link this knowledge with decision making in a most effective way. How to convince decision making to invest in preventive measures to avoid or significantly mitigate disasters. That's very important. That is a COVID show us. How to increase public awareness and perception about living at risk. I will go very briefly through several major points which we need to take, scientists need, and not only scientists and other stakeholders need to take into account to really come to the knowledge be usable, used, and useful. I will be speaking briefly about integration, holism, interdisciplinary, transdisciplinary research, co-design for co-production, action-oriented research before I will come to the conclusion. Let's just make you relax. Probably many of you knows about this fable of John Godfrey Sachs, which is based on the Indian legend. 6 blind men were invited to tell who is an elephant. One approached him and just grabbed the tusk and told, oh, it is an arrow. Elephant is the arrow. Another told, oh, guy, what you are speaking about? He touched the trunk and he told, no, it is a snake. Other touched and told, no, something wrong you are telling. It is a fan. Other guy approached from other side and told, what you are speaking about? It is just a rope taking the tail, you know. And the other took the these extremities, the legs and so on, and they told, no, it is just a very big oak tree. And another guy approached in the middle, and it's it's looked by his hand and told, no, all are wrong. It is a huge wall. And neither of them agreed who is elephant. And this legend, this fable, it concludes. So often in theological war, the disputants are vain, rail on it utter ignorance of what each other mean, and prayed about an elephant none one of them has seen. And this is exactly what occurred in many times, occurred and still occur when we are ignoring something and telling, no, guys, concentrate in this field. It is an earthquake because of rupture that is generate disaster. You know, it's or otherwise they tell it's I don't interesting it is earthquake or something else. I believe this is because of this and this. But the integration is just started. Just meaning compared to the so big time when scientists were already aware about disasters. About a few decades, just started to some integration. And thanks, for example, in scientific area to the integrated research on disaster risk program, which set up by the International Science Council and the United Nations Office for Disaster Risk Reduction. And this small group of the brilliant scientists, and by the way, it is one of the scientists who were vice chair of the this important program was Irazema Alcantara Ayala. It's a very good colleague and friend of mine, and she really contributed quite well to this program. And this program tells a lot of things about this integration research, about the forensic investigation of research, of disasters. And that is a really important issue when we deal with very complicated issues like disasters. Integrated hazard analysis we are using for many years, but still we need to develop more and more about integration. Let's again speak about just the earthquake hazard. What is the principally the people do in the hazard assessment? They calculate this peak ground acceleration, peak ground velocity, as I already mentioned, and that's all normally. But some of them look carefully in the geology and geodynamics in the region, in the hydrology, electromagnetic studies. Geodesy definitely helping this year, remote sensing, earthquake modeling, forecasting, prediction, and indeed physics of earthquakes. And all together can tell us about the comprehensive understanding of earthquake hazard analysis. But it is only what we need. There is many scientists, I believe, even today, they believe that is all what we have to do. But the integration is needed with the physical, social, economic vulnerability, resilience issues, exposure insurance legislation, emergency. I have no time to explain all things, just to mention. The emergency management, media, indigenous knowledge is so important, psychology, medicine, and definitely engineering. This is a convolution of all these parameters together with hazard will tell something about the integrated disaster risk due to only one, as I mentioned, of 300 different hazards. But if all other will come, just mention a few again. It is so complicated, and we are losing them ourselves within so complicated environment. When there are a lot of hazards, together with a lot of parameters related to vulnerability and exposure comes together, and whom to hear, to whom to really the policymakers should look, to the volcano people who are speaking about the big volcanic canopy or flooding, or landslide, the community who tell that it's a landslide are small, but it's really local, generated local disasters. Absolutely true. But how to look in this case more comprehensive way? Holism is needed. And the holism is explained in the best, as I consider, in the book Minds is Eye. If you will look at each small letters, which consist of each bigger letter, for example, this H, it is written reductionism, 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 and go everything reductionism. But if you will look here at the more, if you will zoom this one and down, you will see that, but this is a written holism. Look, Holism, 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 holism. And similarly here, actually it is written there, holism with a small, each letter, big letter, is a holism. But if you will look, it is written reductionism. But if you zoom even down, and you will see, oh my God, it is a something bigger scale. It is M and U. We need really to have this holistic approach to disasters, not going down to very small event, to very small specific hazard, not a digging, down in a very specific area. That is fine to understand some phenomena. That's fine for scientists. But when we are going toward the disasters, I think should make our mind really bigger in terms of the holism, not going down to reductionism and to investigating on very small issues, which is important in general. Transdisciplinary science. We should move in disaster science from pure and disciplinary science through multidisciplinary and disseminated sciences. When we are speaking about multidisciplinary, meaning that the scientists of different fields come together, discuss a special topic, special issue, and then they go back. Each of them resolve this problem using their own methodology. And in some time, they can come together and even put together efforts and write an excellent paper and publish. But it will be multidisciplinary work. But the interdisciplinarity means that they share their knowledge, that they share their methodology. They really diffuse into each other and create from blue and yellow, green. And doing this in co-productive way. And finally, convolving this with the policymaker to get really the informed decision. Let's a very simple way. I like it. It's something which a few years ago I drew, and in terms of the understanding what means there is a simple way, co-design and co-production, because we are today speaking about it quite often. For me, it is I like to visit, especially in Mexico. I like the Mexican food and to go to very good restaurant and to enjoy the meal. And once I compared this, what we have to do in disaster science with our visit of the good restaurant. Scientists, sorry to tell, I am also scientist, that we are some type of veterans. And we offer menu, but we offer menu of knowledge available to help policymaker and to help society. Policymaker and society express their need and they order meal from the scientific menu. But we have to remember, as normal people, a limited budget imposes significant limitations on the willingness of policymakers to pay for disaster risk reduction due to extreme and rare events. They are singing a lot because they are in the office only for 8, let's say maximum 12 years. And the big events, extreme events like COVID comes, let's say every 100 years. Last time it was a Spanish, the influenza. And we need to remember these things and also think the way how properly convince the policymakers and society to pay for the specific dish from the menu. Scientists and engineers with the other stakeholders work in the kitchen, as I show here, and they cook a meal with a principal aim to assist policymakers and society in reduction of disaster risk at local, national, regional, and global level. And finally, they deliver new knowledge, risk assessment, and recommendation to the society and to policymaker. And doing this way, they really satisfy society and policymakers exactly what they need, not what we scientists can do, but what the society needs. And hence we make our knowledge be usable, used, and useful. Finally, about the action-oriented research, very briefly, I just mentioned here of importance of this action. It is indeed transdisciplinary research, but with a specific aim, with a specific action keeping in mind. Here it's the two examples, the Man on the Moon project and the Land Rover on Mars project. And these two projects was very successful. Why? Because they were action-oriented. Unfortunately, nothing like that exists in disaster area, in disaster risk reduction area. And now I will show you examples of implementation. What is the most important? Even the knowledge in general is useful and usable, But if there's knowledge used, and the implementation sometimes tell us about it, how this, the policymakers implement this knowledge. In 2015, the 195 states signed agreement, Sendai Agreement on disaster risk reduction within the next 15 years with the 7 major targets. And these 4 of them were related to the substantial reduction the disaster mortality, the number of affected people, the economic losses, and the disaster damage to critical infrastructure. And 3 the targets which spoke about this substantial increase the number of countries with national and local disaster risk reduction strategies. There is a substantially enhanced international cooperation, which is definitely important. Increase the availability and the access to multi-hazard early warning system. And indeed, there is understanding disaster risk is related to strengthen technical and scientific capacity to capitalize on and consolidate existing knowledge and to develop and apply methodology of model to assess disaster risk, vulnerability, and exposure to all hazards. And now, 5 years later, please look at this map. You see the countries who, and many countries, who never provided data to UN DRR, the data which monitored by this organization. Just a few countries really provided data in advance, and all their targets were validated. Some of the countries provided this target validated data and the reports in progress in several others. Is it a good idea? Here you see some details for each target reporting overview for 2020. It is actually not for 2020, it is reporting here 2020. It's reporting for 2019 when pandemics was not actually ongoing. And there's, you see that at least 124 countries never started even reporting. And that is some type of the implementation. Why? Why it occurred in so many countries? Why we analyze these things actually, and we thought that probably we need to establish all over the world, at least in regions, knowledge exchange central, and using the science diplomacy to really explain the importance of the following of these all 7 targets. And if we will look at this famous VUCA, the problems, which is a VUCA, which is a volatility of vulnerability, uncertainty of risk, ambiguities in governance, and complexity of disasters, which comes in the center with a lot of problems. But the inter and transdisciplinary group of the scientists, DRR experts, policymakers, media practitioners, engineers, all together will generate a product which go back, look at red arrows, with informed decision making, reducing disaster risk, contributing to sustainability, and enhancing resilience. This center would provide a high quality scientific evidence for informed decision making. They will not only contribute to the disaster, to the transdisciplinary studies, but also they promote transdisciplinary education and they bringing together disaster diplomacy at the university level. And they foster to use the disaster diplomacy to inform effective planning and decision making to reduce risk. And the 2 organizations can really provide the help to these bodies. And there's one of them is the National Platforms for Disaster Risk Reduction of UNDRR, and another is the many members of the International Science Council. Not everybody knows about International Science Council. I would like to mention that this council is 100 years old and comprised today of the more than 200 members representing the academies, representing the unions, associations, research councils, and other national and international bodies. And what is quite important, it consists of 16 or I would tell co-sponsor, not consist, but co-sponsor, 16 major interdisciplinary scientific programs, including those which are directly related to the topic I am speaking about today. It's integrated research and disaster risk, as well as some subgroups of the future Earth, like can risk, and also subgroups of the World Climate Research Programs, as well as some others like providing the data, like a PODATA or the COSPAR, dealing with extraterrestrial, the potential hazard and disasters, etc. The IC provide the link between the science to the policymakers, and particularly through organization of United Nations Organization, being the co-leader together with the World Federation of the Engineering Organization to the United Nations Scientific and Technological Community Major Group. And this ISC represents and also participate in many meetings of the United Nations and their agency, provide the input by invitation or independently, as well as involved in several UN advisory bodies, and act also within the agreements with the UN agencies and the program. And most important to mention, several years ago, there is ISC established international network for government science advice, which today is a true link between the science and the policy making at national level. And this is another thing which science should make. It's we need to promote science, and specifically disaster science, at the all levels of the United Nations, specifically at the global platform for disaster risk reduction and other media. Thanks to Irazema, who provided me with these photos, where I had only 3 minutes from scientific community to speak. And that, but it is also something which we need. The most speaking people is policymakers, but not a science. Well, if the scientific knowledge currently available, you will ask these things because I am speaking about useful, usable use, but it's is it really available today to prevent or at least significantly reduce disaster risk? Oh, well, I am sorry to tell no. Despite the knowledge of coronavirus, it is a look. Journal of Time is not scientific journal at all, but it's, if you will look, since 2003 was alerted that it is we have to take carefully all types of the influenza or the coronavirus and so on, particularly speaking about coronavirus. And in 2017, specifically, it was on the first page. It is all first page of Times. And it was written, we are not ready for the next pandemic. Absolutely clear message. And it was true in 2020, early 2020. On April 1st, I published the opinion paper in IC telling about the knowledge-based advice should be really taken by governments, preparedness and public awareness and timely actions. That is a success of coping with the crisis and disasters, like, for example, COVID-19 disaster. And no political and governmental action are productive without having scientific knowledge and important also public awareness raised. Here I show very, very interesting and actually old, about 10 or maybe more years, this poster, which I grabbed from the UNDRR, thanks to them that they allowed me to do it. And that is an excellent map showing that the people should be aware that they live at risk. They should know the safety measures. They should know the evacuation route, and the scientists should help together with the disaster management authorities how to escape during the some extreme events. Unfortunately, it is not the case even in most developed countries. And actually many people, and I particularly was shocked when last year in Germany and several other countries, the flooding took away more than 100 people living just next to the river. They were they had no awareness what flooding can be in this area. They moved toward the river to see how the big wave comes. It is something which were amazing. That's why I put the question that these disasters effect were compounded by lamentable lack of preparedness and the public awareness. It is nothing else. It is actually was a few scientists started to argue, oh, that is a climate change. It's because of climate changes occur. Not because of the vulnerability, but climate change trigger and will trigger. Indeed, the climate change should be taken into account, but it is together with natural hazards, it's a trigger of events, but not a driving forces. And great person I can consider made this statement in one sentence: floods are act of God, but flood losses are largely acts of man. That is, I think, most important to take into account when we see such kind of disasters. And close to the my conclusion, it is a financing disaster risk. Several years ago, I was invited to the workshop of the Earthquake Science and Society, and I put this statement that if only 5 to 10% of funds necessary for recovery and rehabilitation after a disaster would be spent to mitigate an anticipated earthquake, it could in effect save lives, constructions, and other resources. On the right-hand side, you see the risk management and crisis management cycle. But I put it differently in terms of the funding and in terms of the how the let's say natural events differ from the political or economic events, or into with the financing of the disasters. And particularly how earthquakes occur. Earthquakes once occur, it is the stresses which is generated in the lithosphere goes to their minimum. And then they start to grow up towards the next big earthquake. It can take 100 years, 200 years, even 1,000 years, depending on the stress accumulation and its future release. The more time, the larger event can occur. But what occur with the financing? After disaster and impact assessment, a rain of money actually released by the government and different other sponsoring organizations, aid organizations, and so on. It is a really maximum number of funds released. And even at the stage of recovery and construction, the funding starts to be reducing, and the mitigation state even more. And when we come closer to the next disaster, no preparedness and no preparedness receive enough money to really tackle with the future. I mean, the risk is a really issue of the disasters. We need to assess properly this, then we can mitigate disasters. And in my conclusion, natural hazard analysis should be considered holistically and conducted on a common interdisciplinary stage. If we assume that the natural hazard even happened, which is a, let's say, trigger or the causes of the disaster, exposure, and vulnerability, all the physical, social, economic, are the key determinant in disaster risk and the main drivers of disaster loss. Disasters are not natural, but social phenomena. I address you, by the way, it is a very old statement, but I addressed the most recently, a few years ago, the special representative of UN Secretary General put together it's a short short note about this specific issue related that disasters are not natural. Well, today we can hear natural disasters. Some people tell us, as it is term, we understand it is not natural, but the other society don't understand, because society, when they tell the natural disasters, they tell that is the earthquake which really killed my family, not as a building, badly constructed building, you know. And there's we need really this changing of notion that disaster are social phenomena. Outstanding knowledge of disaster risk itself is a little help if we are just thinking about this knowledge. But these disasters, can help in reducing these disasters, I mean this knowledge, if it is implemented into the practice. That's why I put it as only one word for one slide, implementation. And consolidated scientific efforts, which I call this, I dig my own field to find the holy grail, will not contribute significantly to risk reduction without an integrated, co-designed, and co-produced approach to disaster risk research, risk assessment, and DRR implementations. Transdisciplinary approach offered praxis and policy-oriented knowledge to mitigate or to prevent potential disasters. Finally, scientific knowledge should be, as I mentioned several times, and it is again not my words, it is a sociologist saying to them, put together the three terms, three words together: useful, usable, and use. And preparedness and public awareness should be in the heart of disaster risk reduction and global security. We propose a fundamental change in scientific approaches to disaster risk reduction, moving from individual natural hazard studies to disaster science, to integrated science, and shifting the emphasis from the individual hazard and risk assessment dominant in the geoscientific community today to a more comprehensive system approach involving multiple hazard, action-oriented research on disaster risk reduction, co-produced with the other stakeholders, including policymakers, and methods that facilitate the ability of diverse stakeholders to provide complementary perspective. Here is a few sources, and there is a book which we edited together with Jaime and other colleagues. It's a really quite a useful volume where we brought together this knowledge of the extreme hazards, disaster risk, and the societal implications. This is a special report which were produced by the group of the scientists from the International Science Council, and the executive summary were distributed among the participants of the Sendai Conference on Disaster Risk Reduction 2015. And this is a paper which really summarized our efforts for the several years dealing with extreme natural hazard, disaster risk, and their societal implication. Thank you very much for your attention, and I am really pleased to be together with you today during this lecture. Thank you.
Alik, thank you very much indeed for this very alluring and provocative presentation. Really, I'm impressive about all the information that you present us. And no doubt that we are living in a very dynamic planet. And some of this dynamic is provoke this kind of effects that affect the society and the humanity. So we have some comments, congratulations, and questions. So I will move in for that if you don't have any inconvenient. Okay. Some people said that thanks for the lecture. It's a very interesting way to connect the natural phenomena and risk assessment, and ask how probabilities are estimated for an earthquake or hurricane. And the second is related is what data are needed for modeling hazards and risk.
I will answer the following. There is really there is not so simple to answer you directly. There is how the hazard can be specifically mentioned in terms of the probability, but because it's a really issue to discuss in another lecture. But very briefly, the probability should be, in my opinion, it is a scientific issue, it's a mathematical, statistical issue related to the finding the, let's say, probability for a specific event. And it is based on the many factors. It's based on the history. It's based on the particular event which happened and so on. But the most important is how we deliver this probability to society.
Okay.
And this is something which we not yet discussed at the major in the scientific community. How the probability which we understand should be transferred to the society. This is an issue, for example, occur, as I understand, in after the 2009 L'Aquila earthquake in Italy. And this was the case when the scientists mentioned that the probability of this earthquake is not so high. It doesn't mean that the earthquake will not occur. And the probability of the event are determined in a very complicated way, as I mentioned. But we are speaking now about the, let's say, earthquake probability or the forecasting probability. It is a theory and it's really a quite interesting story. But if we are moving closer to the issue of risk, risk can be estimated even without available today data. And because we know, even evolving, but we know there's some major patterns of vulnerability. We know the exposure, which also is time dependent. And we know time dependent the hazard. That's why this makes the complications. And this makes complications in terms of the convolution of the three parameters. But nevertheless, it is possible to assess. But again, the point is that not always all data are available for us to make a really very, let's say, proper or the strong estimates of the risk. How is risk high, or maybe it is not yet so high to be really transferred to the state or to policymakers.
Okay, thank you, Alik. I will translate. Mary Bensor say hello and congratulations, and she said that it's a great honor to listen to you. And she said that she is living in the Baja California, it's in the southwestern part of Mexico, and she said that she is living on the city. She is living on the city on the San Andres Fault in California. And there is a question about it. This, in the seismic regions like in California, how can we improve resilience? Is this possible? And how is the vulnerability estimated?
I don't know exactly how in your country the vulnerability is estimated. I think it should be directed to specific people who are dealing with the vulnerability in the region. But when we are talking about the San Andres Fault, it is a really very important fault in this area, western coast of the US and the Mexico. And there is importance is again, because it's even there is very many centers studying these earthquakes on the San Andres Fault, but still today the predictability is not at the level when we can tell very precisely, okay, look, we know exactly that earthquake will occur at some specific time. But again, we should clearly remember that it is a prediction is not only the telling the people earthquake occur. We need to tell where it occurs, the time when it occurs, and the magnitude, which is important. Because earthquake occur every second, you know, with magnitude -1 or 0 or even 1. but it's important, it's really to make this range of the magnitude, range of the territory, and the range of time, and tell within this period of time and so on that will occur. And another important issue, which is one of colleague of mine, she is developing for many years, it is bringing together scientists and the governments of, for example, San Francisco or Los Angeles, you know, and I would advise also the scientists in your country also to come closer to the governmental offices and to really explain them importance of dealing with the earthquakes, and not only based on the, let's say, increasing the resilience of particular society. Definitely in general, yes, but also looking at specific area. For example, if you have some water dams, and what can be done with this water dam if the earthquake with magnitude of such and such can occur, let's say, in 2 years. What should be done? You know, there are many other issues. Why? Because again, it can occur that the damage of the dam can flood the territory, and the flooding will take lives and the generate other losses even higher than it is because of the earthquake. Maybe they suggest buildings will be quite resilient to the earthquake, but such kind of things, infrastructure will not be resilient, and then in this case it will can generate a really disaster different types, but triggered by earthquake. And that's why my advice actually is not look only to the scientists, but it's come closer to policymakers, and this is an important issue.
Okay, I will let the questions about the policymakers at the end, but because some people are asking about they say that very interesting presentation on important and very relevant research. And as the Lisbon earthquake caused major damage and human losses, what was more damaging or caused major damage, the earthquake or the tsunami?
Very good question. Yeah, thank you for the question. It's good because it is the first question which I asked my colleagues, Japanese colleagues, you know, after the 2011 earthquake. They told me, oh, at that time, you know, so complicated question. But then they thought a little bit more and they consulted and so on. They told probably 5% of the damage because of earthquake and all other because of tsunami. And actually, I have a movie, not movie, it's a video movie. I mean, it's done by my colleague who was at that time in Tokyo, and just on the street, he was walking and suddenly he felt this very big shaking. And he immediately took the telephone, put that, at that time already the telephone were available for video making, and he made a video of 2 huge buildings, very tall buildings, about some 40, 60 store building, you know, and you could see how they were shaking actually, very slow, this wave, and they did like that, exactly like I showed you. It's something like a 5, you know, degree. I was shocked, but they were shaking, and then they stopped after about 5-10 minutes. It was amazing. Nothing happened. And yes, definitely it was not Sendai, but it was just a Tokyo, some distance, but still it was a magnitude 9.1. That's why it is sometimes we are, especially in Japan, it's very well prepared. And similarly, for example, in Mexico City, when I visited this very tall building, and even I went up to this top of the building to see the seat and so on. And it was a really fantastic description about how this building survived during the earthquake which occurred in the city, even at the place where the soil was not very good, but still very well built the construction which survived during this period. But anyway, it's answering the question, it's like that, something like 5 to 25 in Japan. but in each individual cases, it can be different, definitely.
Thank you. In your talk is remarkable that it's necessary the communication with the policymakers. And you know that in many countries, this is very difficult, but it is more difficult in developing countries like us, like in Mexico or sub-Saharan region and so on. And respect to that, Iracema asked you, what can be done for policymakers to really understand disaster risk and to address underlying causes and disaster risk drivers? Many things in advance. Say that.
Thank you very much, Iracema. It's a quite good but very complicated question. I think there is not a simple answer to this question. It depends on the country. It depends on the approach. Yes. It depends on the policy making in a specific country. I consider that it's in each individual case, it is possible. We are scientists. We are most, clever people in the world, and we should find a way to those who are in the places where they take a decision. And once I was told when I was young, how to get a good job. Just try to meet the leader of this organization, let's say CEO. Come and tell this person, I know the way how to make you rich. 90% that you will get a job. And I think we have to find a way to government to tell, I know how you to stay next time in the office. Another 4 terms, another 4 years, or another term to the office. Let's do this, this, and this. And we can help you in promoting this area. Again, it depends. It's not a simple question. It's how we can convince them to do. It's really very complicated. And the social scientists, policy scientists should work probably even more, let's say, enthusiastically, I would tell, to in this area. Because today we see that even in the most developed countries, there is a policy making and the scientific knowledge are not properly used. Could you imagine that at the beginning of the COVID-19 in Germany, German government told, don't take a mask. It is absolutely unnecessary. Masks are not useful in the COVID area. When it was huge experience of the many countries that it's a mask, it's really prevent at a specific level that prevent the people to be infected. Well, later definitely they changed their mind and so on, but initially this message came to the society. That's why it is sometimes very complicated to understand how to link all these pieces together. I don't know I answer your question or not, but it's thank you for the question. It is one of the important questions, really, how to make them to implement at least partly, at least 50% of scientific knowledge in their day-to-day life.
Yeah, I know it's Thank you, Alik. I know that it's a very complicated question. It is a challenge, and it's a challenge like for us, like countries like us, like Mexico. That is we don't have not too much resources for sciences, and we need more, and we need to improve our communication with policymakers. Well, and Raquel Gonzalez Maqueda said, thank you, Professor Alik, for such a great lecture. Greetings from Mexico City. And Diana asked, climate change is responsible for the recent increase on disaster risk. I think you mentioned about what is the role of climate change in the natural hazards, and maybe we can comment a little bit more about it. That because
yes, thank you very much for the question. I understand. Thank you very much for the question. Actually, more recently, I mean, I published a paper telling that the natural hazard and climate are not drivers of disasters, and it was in natural hazard publication. When I wrote about these things, actually, I was triggered by this event which happened here in Europe and the flooding. And there's also by the comments of several scientists, climatologists, telling that is because of the climate change. Well, it's indeed the climate change. It is a trigger. It is indeed, there is a report of IPCC tell us that it is a trigger of the earthquake and the increase of the extensity or increase of intensity of the events, these hazard events. But when we are speaking about disasters, it's a little bit different issue. It is different stories because it is a really vulnerability, and the vulnerability different types, as I mentioned. It's not only physical but also economic and also sociological. And there is awareness is a part actually of the social vulnerability. With no awareness, it is a very big vulnerability because the society don't know how to act during the extremes. And this is something which we have to take into account. And speaking about the climate change, again, indeed, there is a special cases when the climate change directly affect and directly generate the disaster to environments, and very complicated to, let's say, deal with this. And this is climatic hazards, especially related to wildfires and droughts. However, sometimes droughts initially considered to be the induced by natural hazard climatic change as event, induced disaster, but the later it can be not only because this one, but it's because of the handmade. And it's particularly World Meteorological Organization considered this 2011 East African drought, and they looked it carefully, and they found the first year, this was yes, it's like the things which were because of the climatic change, because of the increase it's many others concatenated, let's say, hazards. But later it becomes a more human-made disaster in the countries. And similarly the wildfire, it's they are indeed induced by the intensity of the fires induced by climate change, and we need to take into account the climate change. There's no nonsense, but we have to really put these components, analyze these components some separate way. Natural hazard, climate change on one side as a trigger of the disasters, and vulnerabilities, different vulnerabilities and exposure on the other side as a drivers of disasters. Because again, we mentioned disasters are not a natural events, but it's mostly they are social events. You are muted, Ligia. You are muted.
Sorry.
Yes.
The proxy data are useful for the modeling or simulation of natural hazards, because you were talking about the observations, the monitoring different through the time, but we have currently instruments and so on. But we have also proxy data that can explain us what happened in the past. We have deposits, tsunami deposits, and so on. They are useful for your investigation and simulation and modeling? It's my question.
Absolutely.
Sorry.
Excellent. Alicia, excellent question, but it's important. When we are speaking about the individual hazard, for example, I spoke about the earthquake, it is very complicated to determine the magnitude of earthquake which occur, let's say, 2000 years. Even for this case, there is some part of science that's called paleoseismology. The people go to the field, they make there's some area exposed, and they expose the area, and they look how the fault is traced this particular area. But they cannot trace the entire fault which generated magnitude 9 earthquake. They just look at the very small area, and maybe in this small area, even this fault generated magnitude 9, but this area will show something like magnitude 6, because at this segment of the fault, there is let's say slip was quite smaller than general slip at the all fault. You know, and this is a complication. Indeed, there is such kind of the data is quite important, and even interpretation of the paleoseismological data. That's why the more data we have, the more reliable conclusion we can bring to the table of, in terms of the prediction, in terms of the forecasting for some specific events, or even just using this information in the hazard assessment.
Thank you very much, Alik.
You are very welcome.
And Jaime, maybe you have more questions or comments?
Thanks. Thanks very much. Well, it's a very interesting and insightful lecture. Thanks very much, Alik. And the message, I think, is very clear. It's the importance of integrated analysis for risk and disaster studies. And it is a critical message to our policymakers, but also to the research community and to us as a society. We need to analyze in an integrated way, including, as you described, the social part. So thanks. And I particularly enjoyed your analogy on the risk and hazard menu. It's a very interesting way of involving our policymakers and us. And it seems extremely useful. And also these exchange centers. And congratulations on your work and also both your interest in having the results of the research results used in the policy making. I think this is essential, and through all the efforts, including the Sendai agreement, the protocol, and all, this is something we really need. I really enjoyed the presentation, and we will send it to our policy makers here and recommend. It's actually great that the conference is a part of the AGU Distinguished Lecture Program. So we are reaching a much wider community, and the international collaboration is a major priority for the UNAM Foundation and well, this Consortium of Universities for Science. So thanks, Ligia, also for making this possible, and Alik, congratulations.
Thank you very much, Jaime. And I would like just to mention that this lecture was really very specific. And I actually like this lecture just because this lecture showed a little bit about this link between the science, which I love. I love the mathematics, you know, I love the geophysics, and I love to do science, real natural science. But it's in 2004, I just thought about how much my modeling is helping to society. When I saw within the few hours, 250,000 people passed away because of the tsunami which generated earthquake. And I thought, what I am doing, that's just a modeling. Let's think about how our model, our knowledge, can be used and can be useful. And at that time, I started to think a little bit more about this how to bring all components together. And that's way it's, even I like to give a purely scientific work, and I appreciate for the last few years the possibility to give these talks which bridge a little bit these all components together. Indeed, it's something which should be done in at least in the future in the way like, for example, in America, it's called the convergence way, or in Europe, other places, it's called the integrated research and so on. But it is truly integrated, it is truly diffused inside of it. I remember there is a talk by Marcia McNutt, who is today president of the National Academy of Sciences. She told during one of her speech that, you know, the people should construct the one building, and within the one building to put together professors of different disciplines who are dealing with natural hazards, social issues, engineering, policy making, etc., the media and so on. And they are students together. And every day they should meet, they should exchange what they found, that is truly, that's interdisciplinary study, interdisciplinary education. I absolutely agree. Nothing better than this also simple description. Put people together. It is not just on the paper, you know, that we created new interdisciplinary center, people sitting in their own buildings, you know, teaching their own students, sometimes come together. But anyway, this is something which is important, and I think it will be going further and further with all nations will appreciate it. Thank you.
Oh, thank you very much again, Alik. And so we are moving to the end part of the program, and we are moving to with our president of the National University of Mexico Foundation, Dionisio Mead. Please, Dionisio.
Thank you very much again. It's been a very great presentation. And I would like to remark some very essential points for me. Nosotros hemos insistido en que este espacio y estas experiencias recientes, como la de la pandemia, acreditan que soportarse en la ciencia es una muy buena decisión, y que quienes se han apoyado en la ciencia tuvieron mejores resultados en la lucha contra la pandemia que quienes no lo hicieron. Y eso nos lleva a insistir mucho en que en esta nueva realidad, una parte muy importante de lo que se tiene que hacer es respetar a la ciencia y respetar a los científicos. Y respetar a la ciencia y respetar a los científicos implica dedicar recursos para este propósito. Y yo creo que aquí se nos ha venido subrayando un dato muy vital. Es cierto que los desastres generan a veces costos muy elevados y costos en vidas humanas. Y es cierto también que en ocasiones parece ser el azar el que genera estas adversidades. Pero lo que aquí se ha presentado acredita de manera muy clara que muchos de estos desastres, si bien pudieran haber sido inevitables, sus impactos se pudieron haber atenuado de manera muy sensible si se hubieran tomado las medidas correctas para evitar que su impacto fuera tan destructivo. Y yo creo que esa es una gran lección que tenemos que llevarnos de esta plática. Efectivamente, el diálogo entre los investigadores y el diálogo con quienes definen las políticas públicas es una parte crucial de la relación entre la academia y la definición de estas políticas públicas. No podemos dividirnos en este espectro, y yo creo que aquí hay una gran lección, porque muchas de las experiencias que aquí se mencionan son experiencias que, si bien no pudieron haberse evitado, sí se pudieron haber atenuado los impactos en cada uno de los datos que ahí se mencionan. Y efectivamente hay algunos aspectos notables. Por ejemplo, hoy es posible en algunas ocasiones tener la noticia de que ahí viene un temblor. Y yo creo que tener ese breve espacio para poderse preparar frente a esa adversidad ha implicado un avance notable de la ciencia, pero deben ser más. Hoy se pueden predecir con mucho más oportunidad cuando se acercan ciclones o huracanes. Y yo creo que eso debe implicar una política de prevención de los daños públicos que acreditan la urgencia de soportarse mucho más en la ciencia. Yo creo que los accidentes aéreos nos dan también una buena lección. Cuando hay un accidente aéreo, a veces se recupera hasta la última pieza del avión accidentado para tratar de conocer qué fue lo que motivó ese daño y tratar de evitar que se pueda repetir una circunstancia similar. Y en ocasiones esta investigación ha llevado inclusive a modificar patrones de conducta de quienes conducen las naves para tratar de adecuarse a esquemas que sean más seguros para el avión que maneja. Y yo creo que este ejemplo y otros muchos, como los que ha mencionado ahora nuestro especialista en la plática de hoy, acreditan precisamente esta urgencia. Y yo creo que subrayan muy bien la urgencia y la conveniencia de que tomemos en cuenta estos avances científicos, y yo estoy seguro que muchos de quienes han escuchado esta plática podrán hacer de este estudio de la ciencia y los desastres una especialidad a la que puedan dedicar su futuro profesional. Agradecemos mucho la presentación que nos has hecho hoy en esta tarde. Agradecemos a Jaime, agradecemos a Ligia, agradecemos al doctor Alik Ismail-Zadeh por esta presentación tan formidable, y los invitamos a que sigan en contacto con nosotros. Vamos a volver a tener nuestros documentales por la ciencia el próximo jueves a las 3. Vamos a tener nuestra próxima plática el próximo martes a las 12, tratando de ver cómo se puede aplicar la ciencia al futuro desarrollo y cómo tenemos que vincular cada vez más la investigación científica a la definición de políticas públicas. Es un error que estén desvinculados y tiene consecuencias, como aquí se ha mencionado, que pueden ser verdaderamente imprevisibles. La investigación científica desvinculada del impacto que puede tener en la realidad estos efectos puede parecer un poco ociosa. Y yo creo que este vínculo acredita la urgencia de que vayan de la mano la ciencia y la definición de políticas públicas. Desde luego esto implica generar y aplicar más recursos a esta finalidad, pero yo creo que el avance científico demanda con urgencia que se le apoye en sus objetivos, que se le apoye en sus fundamentos y que se le apoye en su investigación. Muchas gracias, Jaime. Gracias al profesor Alik Ismail-Zadeh. Gracias a Ligia por habernos ayudado con la moderación de este evento. Gracias a Araceli por haber estado con nosotros la tarde de hoy. Gracias a todos y muy buenas tardes.
Fundación UNAM, en su compromiso por la divulgación de la ciencia al alcance de todos, continúa con la tercera temporada del ciclo de documentales Nuestra Nueva Realidad, Jueves de Ciencia, en conjunto con el Consorcio de Universidades por la Ciencia, transmitido por la señal de TV UNAM y nuestras redes sociales. Cada jueves presentamos temas relacionados con el gen, una historia personal, el misterio de los cristales gigantes, luz en la Tierra, H2O, la molécula que nos hizo, viajes geológicos, así como el comportamiento de las plantas. No te pierdas las transmisiones los jueves en punto de las 15 horas por la señal de TV UNAM y en www.fundacionunam.org.mx.